Hi everyone. In this video lecture, now we will look into those chemical reactions of carboxylic acid where your complete carboxyl group, that is COOH group, would be involved, and the second type of reaction where only alkyl part, that is R part, RCOOH is carboxylic acid, where only R part is involved, right? So this is your carboxylic acid. Right, it has this carboxyl group COOH, it has R group, right? So we will be doing two types of reactions. First reaction where the COOH would be involved, the second reaction where only this R group would be involved. In the first type of reaction where the COOH group would be involved, we will look into two types of reaction. The first type of reaction are decarboxylation reactions. Right? Decarboxylation simply means, D means removal, carboxylation is removal of CO2, this CO2 from carboxyl group, right? The second is we will look into reduction reactions. In reduction reaction, this complete COOH would be reduced to CH3, right? So we will be looking into partial reduction where carboxylic acid will form alcohols, then complete reduction where carboxylic acid will form alkanes. Right, so let's quickly look into first decarboxylation reactions. There are some ways of carrying out decarboxylation. Decarboxylation, that is carrying out removal of carbon dioxide from carboxylic acid, and carbon dioxide would be removed from this carboxyl group only. The first way is by treating sodium or potassium salt of carboxylic acid with soda lime, right? Soda lime we know is sodium hydroxide plus calcium oxide, right? So when you treat sodium salt CH3COONA with soda lime, it will form your sodium carbonate, right? It will form carbon dioxide because your carbon dioxide would be removed and the main product is your alkane, right? So in this would be reduced to hydrogen, so it will form CH3 dot, it will form H, so it will form CH4, right, plus your sodium carbonate plus CO2, right? Similarly, if you take C6H5COONA sodium benzoate and treat sodium benzoate with soda lime, right, it will form C6H6 plus sodium carbonate plus CO2, right? This is one way, right? And second type of reaction is electrolytic reaction where aqueous solution of sodium salt of carboxylic acid will undergo electrolysis, right? So it will form it will form carbon dioxide gas at anode, right, and an alkane. So let's look into that reaction. Let's take CH3COONA, right? It will undergo, when you electrolyze it in aqueous solution, it will ionize and will form acetate ion plus sodium ion. You have aqueous solution, that means water, it will form hydrogen ion plus hydroxyl ion, right? So when we say hydroxyl ion, when you pass electric current through solution containing these ions, then these ions will migrate at respective electrodes, right? So let's see at anode. At anode, your acetate ions will migrate and your OH ions will migrate. Acetate ions will discharge at anode, right? So acetate ions, two acetate ions, right, will lose two electrons, right? It's an anion, it has negative charge, so it will lose two electrons and will change into alkane, and carbon dioxide would be released at anode. Now let's see at cathode. At cathode, hydrogen ions will migrate and your sodium ions will migrate. Out of these two, hydrogen ion has more reduction potential, so it will gain electrons that are lost by these acetate ions, right? So two hydrogen ions will gain two electrons to form two hydrogen atoms, right, which will form hydrogen gas at cathode, right? So your decarboxylation is carried out via electrolysis, and this electrolysis is known as Kolbe's electrolysis. This is known as your Kolbe's electrolysis, right? I hope this is clear. This is simple electrolysis that we have done in previous classes also, right? So this is it. Now there is a second way of doing decarboxylation where we do dry distillation of calcium salts of fatty acids, right? So by heating, or what we call it as, we heat calcium salts of fatty acids. When you heat calcium salts of fatty acids, it will give you aldehyde or a ketone with the removal of carbon dioxide, right? For example, if you have HCOO Na, calcium, it's a calcium salt, right? So when you heat it, or what we call it as dry distillation of calcium formate, right? Dry distillation, right? So what it will form is your HCHO plus carbon dioxide. HCHO is your formaldehyde, right? Similarly, if you take CH3COO whole twice calcium, you do dry distillation of calcium acetate, it will form CH3, right? COCH3. This is your acetone plus carbon dioxide plus calcium carbonate. It will form. So the main product here is your it will form calcium carbonate. Right here also, it's not carbon dioxide, it is your calcium carbonate. Sorry for this. Right? So it will form aldehyde or a ketone. Similarly, if you take now, so this is here you obtained ketone, here you obtained aldehyde. So when you do dry distillation of the mixture of calcium salt of a fatty acid with calcium formate, you will get aldehyde. For example, if you take calcium formate and heat it with CH3COO whole twice Ca, on dry distillation it will give you CH3CHO, right? This is your acetaldehyde, right? Plus you will get calcium carbonate. Similarly, if you treat calcium formate with calcium benzoate, it will form benzaldehyde, C6H5CHO plus calcium carbonate, right? So this is also your decarboxylation reactions where your CO2 group is removed, right? COO group is removed in the form of calcium carbonate, and what you got is aldehydes and ketones. And remember, when you heat calcium formate alone, dry distillation of calcium formate will form formaldehyde, and when you take any other salt of calcium, any other calcium salt of fatty acid, you will get ketones, right? And when you take mixture of calcium formate with any other salt of calcium salt of fatty acid, you will get aldehydes, right? I hope this is clear. Now there is another important reaction where decarboxylation, that is COO group, would be removed from carboxyl group or carboxylic acid, is your Hunt's-Decker reaction. This is your Hunts-Decker reaction. Right, now let's see what happens in Hunts-Decker reaction. In Hunts-Decker reaction, we take silver salt of fatty acid treated with bromine in presence of carbon tetrachloride. Right, it will remove carbon dioxide and will form alkyl halide. Silver salt of fatty acid, that is, let's take silver acetate, CH3 COO Ag plus, treat silver salt of fatty acid with bromine in presence of CCl4. We call it as refluxing with CCl4. It will form alkyl bromide, that is, in this case, methyl bromide plus CO2 would be removed plus silver bromide. Right, this is one way of carrying out decarboxylation reaction, where you treat silver salt of fatty acid with bromine, refluxing with refluxing carbon tetrachloride. It will form alkyl halide. In this case, it is methyl bromide plus CO2 would be removed and silver bromide will get formed. Right? I hope this is clear. Now let's look at the other type of reaction where only R group would be involved, and we have a very important reaction. We would be doing only one reaction, and that's a very important reaction. We call that as Hell-Walhard-Zielinski reaction. Right? So let's do that. Let me just rub this off. Just remember the name reactions. This is your Hunts-Decker, and the other reaction would be your Hell-Walhard-Zielinski reaction. Right? So Hell-Walhard-Zielinski reaction. Right? This is abbreviated as HVZ. Right? So this is basically chlorination of carboxylic acid, chlorination of hydrogen at alpha hydrogen atoms. For example, if you have CH3 COOH, right? If you treat acetic acid or carboxylic acid with chlorine or bromine, right? Then the alpha hydrogens would be replaced by a chlorine atom. That is, halogenation will occur at alpha hydrogens, right? And all three hydrogen atoms would be removed, right? And in case of chlorine, even this halogenation will continue till beta hydrogens as well. So let's look at the first reaction, where you treat chlorine in presence of red phosphorus. Right? You treat this acetic acid, right, with chlorine in presence of red phosphorus. So what it will form first is Cl, CH2, COOH. Right? In this, one hydrogen atom is replaced by chlorine atom. Right? So what acid is formed? Right? This is your monochloroacetic acid. Since one chlorine atom has replaced one hydrogen atom, so this is your monochloroacetic acid, and this reaction will continue in presence of red phosphorus. It will form Cl2 CHCOOH, right? And it will continue and it will form Cl3 CCOOH, trichloroacetic acid, right? Where all alpha hydrogen atoms, right? This is just to understand what is alpha hydrogens. This is your carboxyl carbon, right? And this next to carboxyl carbon, this is your alpha carbon, and all hydrogen atoms connected to alpha carbon are your alpha hydrogens, right? So in the formation of this trichloroacetic acid, right, your all hydrogen atoms of alkyl group, of this alkyl group, are replaced by chlorine atom to form trichloroacetic acid, right? I hope this is clear. Now let's look at bromine, right? Reaction with bromine. Reaction with bromine, it will again occur the same way, right? Bromination take place, okay, I have already told that. So suppose now let's take another acid. You have CH3, CH2, COOH. Right, it will react with bromine in presence of red phosphorus, where both these hydrogen atoms, these are alpha hydrogens, would be replaced by bromine. This is your propanoic acid, where two hydrogen atoms are replaced by bromine atoms, right, to form dibromopropanoic acid. And this is your Hell-Volhard-Zielinski reaction, right? Now, just one thing you need to look at here is, if you do chlorination, right? Chlorination, that is reaction with chlorine. Chlorination can replace even these beta hydrogens. These are your alpha hydrogens, these are your beta hydrogens. If you take chlorine in this case, then this chlorine will replace even these beta hydrogens. But bromination will not replace these beta hydrogens, it will replace only alpha hydrogens, right? Just remember that. So I hope all this is clear. In this lecture we have studied reactions where COOH group has taken place. COOH group is involved, right? We have seen decarboxylation reaction, right? And we'll just again now we'll see reduction reactions, right? Then we saw reaction where only R group is involved, right? Which is your Hell-Volhard-Zielinski reaction. Now let's look into reaction where again we missed this reduction reaction, so we will be looking into reaction where COOH group would be reduced to CH3 group, right? First we will look into partial reduction, right? Then we will look at complete reduction, right? In complete reduction, this COOH would be replaced by this CH3. Let's look at partial reduction first. In partial reduction, you treat acetic acid with hydrogen in presence of, you treat acetic acid with hydrogen in presence of copper chromite, right? In presence of copper chromite or lithium aluminium hydride, right? It will form CH3 CH2 OH, right? This is your reduction reaction. Just notice oxygen has reduced, right, in the resulting compound, and your hydrogens are added. Basically you can see that COOH group is reduced to CH2OH group. These are your alcohols, right? And if you take lithium aluminium hydride, CH3 CH2 COOH, 4 hydrogen atoms, right, in presence of lithium aluminium hydride, right? 4 hydrogen atoms will react with propanoic acid, where the COOH group will again be reduced to CH2OH, like I said here. So CH3 CH2, this COOH will reduce it to CH2OH. This alkyl group will remain as it is. COOH would be reduced to CH2OH, right? So this is basically your partial reduction. Partial reduction of acetic acid, of COOH group, basically, right? So this is what is formed here. Now let's look at complete reduction, right? In case of complete reduction, what we will do is acetic acid is treated with hydrogen iodide It is treated with hydrogen iodide in presence of red phosphorus. Right, in presence of red phosphorus, it will form CH3, CH3, right? Your COOH, this is your complete reduction of acetic of COOH. COOH will be reduced to CH3 group, right? This is what is happening here basically. So CH3 and this COOH would be reduced to CH3, right? And this is what is formed, right? Plus you will get iodine and water here, right? I hope this is clear. Right, just balancing this equation, you have 6, so you have 3 here and 2 here, right? I hope all this is clear. So this is your complete reduction. This is your complete reduction. And this is your partial reduction. In partial reduction, your COOH is reduced to CH2OH. Right? You can see this is not complete reduction because one O oxygen is still here. In complete reduction, all these oxygen are reduced and they have changed, it has completely changed into CH3. So this is a complete reduction. In complete reduction, alkanes will get formed. In partial reduction, your primary alcohols will get formed. Right? Just remember all this. I hope all this is clear. Thanks.